Hey guys, today we're going to look at lesson 2.4, Solve and Graph Nonlinear Systems. Alright, so the first question says solve by graphing. Alright, so when we solve by graphing, we're looking for the intersection points. So you can see on the graph that the line and the parabola intersect at one point here and a second point up here. All right. So it says a system contains a parabola and a line. The graph of the parabola is given y equals x minus 2 squared, and the graph of the line y equals 3x minus 6. All right, so we can say the parabola and the line intersect at, so let's say 1, 2, that's at 2, 0. And then again at this point up here, which looks to be at 5 and over to 9. So 5, 9. Remember, we always do ordered pairs, x and then y. All right, so it says the solutions of the system are, well, the solutions are the intersection points, so those should be the same answers. So if you find the intersection of two equations, those will be your solutions. All right, now it says to verify our solutions. All right, so we're going to verify our solutions. So let's go ahead. Let me see if I can get my pen working here. All right, so we're given two equations. We're given one equation, y equals x minus 2 squared, and we're given a second equation here. So let's look at this equation here first. This is our quadratic. All right, and we said that we have an ordered pair. So our ordered pair is 2, 0. We're going to check this point first. This is our x, this is our y. Always an ordered pair is in x and y. And that's important because what we do to check it algebraically is just plug these points in to see if it works for both equations. So we're checking this equation first. So we're going to say 0 is our y. So does 0 equal, and x is 2 minus 2 squared. 2 minus 2 is 0. 0 to any power is 0. So 0 equals 0. So this point works for this equation. Now let's check it for the other equation. So the second equation is y equals 3x minus 6. So we're going to do the same thing, plug 0 in for y. And 3 times 2 minus 6. This is 6 minus 6. 6 minus 6 is 0. So this point works for both equations. That means this is a solution, and even though we've seen it on the graph, the intersection point, we can check it algebraically as well. All right, let's do the same thing for the other point. Let's switch over to red here. Let's check 5, 9. Okay, so again, 5, 9 is an x and a y. It's important that you plug in the right number in the right spot. So 9, so we're going to have y equals x minus 2 squared. So 9 would be our y. And we're checking to see if this equals 5 minus 2 squared. All right, 5 minus 2 is 3. 3 squared equals 9. So 9 equals 9. So that one works. All right, check the second equation. Y equals 3x minus 6. We're going to plug in 9 for y. We're going to plug in 5 for x. And does 15 minus 6 equals 9? It does. So that is correct as well. So a system of equations is two or more equations, and their solutions come from the intersection points. And again, we just verified that algebraically. So it says 0 equals something minus 6. You can see that comes from the second equation here. So let's see, 0 equals 3 times 2 minus 6. So 3 times 2 minus 6 And then our other equation was 2 minus 2 squared. So 2 minus 2 squared. And this side, this is our other point. So they did the linear equation first. So we got 3 times 5 minus 6 equals 9. And 9 equals 5 minus 2 squared. So 5 minus 2 squared. All right, let's look at another system of equations. This time we're given a circle and a line. So we're given a circle and a linear equation. So it says the system containing a circle given by x squared plus y squared equals 16 and a line y equals negative 3x plus 4 are shown. One solution is, okay, so here's 0, 4. 0, 4 is one solution. And this point here, this point is not an exact point. So you can see that it's not quite, it's not on an exact point. So when it's like that, sometimes I like to blow it up and just kind of look at it a little bit more detailed. It's going to be just past 2. So it's going to be 2 point something, and it's going to be just below negative 3. So let's see what our choices are. Alright, so 2 point something, 5 over 16, 5 goes into 15 3 times. We can automatically eliminate that one. 5 goes into 8, 1 3/5, so that's not quite 2. And 5 goes into 10 2 times and 2/5 left over. And let's see, if we come down to negative 3, 5 goes into 15, negative 3 times. So that is the only one that could be the solution. So it is a little bit more tricky when it's a fraction, but if you just think about where it's located on the graph, especially if it's a drop down, it's easy to eliminate choices. Okay, so now we're going to verify our solutions. So let's see what our equations are again. All right, let's start with the linear equation this time. So we're going to start with this, and we're going to check 0, 4. So we're going to say, does 0, 4 work for this equation? So we're going to say this is our x, this is our y, so y is 4. Does 4 equal negative 3 times 0 plus 4? 4 equals 0 plus 4, so yes, that works. All right, let's check and see if it works for the circle as well. So we're going to have 0 squared plus 4 squared. Does that equal 16? Okay, so x was 0, y was 4. All I did was substitute that into the equation given. 16 equals 16. So we can see that that one checks out as well. All right, now with the fractions. So this will be a little bit harder, but let's see what we get. All right, so we're going to do y equals negative 3x plus 4. This time our y is negative 16 over 5. And we want to know if that equals negative 3 times 12 over 5 plus 4. All right, so this becomes negative 36 over 5. And then we need a common denominator. So 4 is the same as 20 over 5. 5 goes into 24 times. All I did was make a common denominator. Negative 36 plus 20 is negative 16 over 5. So that does work for the linear equation. All right, let's see about the circle. So we're going to have 12/5 squared plus negative 16/5 squared. And we want to know if that equals 16. Alright, so this is going to be 144 over 25. And then 16 squared is 256. Negative 16 squared is still positive because anytime you square your number, it's going to be positive. So, and then does that equal 16? So we've got 256 plus 144 is 400 over 25. And 400 divided by 25 is 16. So 16 equals 16. So we can see that these are verified as well. All right, so with that, we have something plus 4. So this is our linear equation we're talking about. So what number did we plug in first? We plugged in negative 3 times 0. And then for this one, we did negative 16, negative 3 times 12/5. All right, and on the left side, for our linear equation, we did 4 squared. Right up here, we did, oh, that's our circle equation. So we did 4 squared, and then we did negative 16/5 squared here. So that should be what they're looking for. So it always helps to kind of go through what these steps are, like actually work it out instead of just looking at these drop-down boxes, because these can be a little bit confusing if you just look at this without actually checking it and doing the work. All right, so system of equations. You're going to find the intersection point and you can check it algebraically. If you have any questions, please let me know.